Okay, so in this video, I'm just gonna run through kind of the basic setup of the experiment. The two things that are, or the three things that are left to do are to glue screens, the ones that we'll bring from New Haven, um, finish setting up the pressure transducers with the circuits that we're having printed, and then finally to work on mounting stuff in the box. In this video, we're just going to show the basic setup of the experiment and not run any test runs because the screens that we set to dry yesterday, we want to give a little bit more time to dry, and then the rest of the screens will get glued over the next few days. So let's get started with just basically a walkthrough of the experiment. So starting with the cells, the test screens are in the cells right now. That's the 1-inch radii cell. Right now we have the coarse titanium in there, I think. And this is the two radii cell, the 3 radii cell is back there, and then finally the 4 radii cell, let's see, it's in the back there. So the basic layout of it is, like we were talking about, we have everything in 3 groups of 4. So you can see there's 4 cells there, 4 cells there, and 4 cells there. And then the pumps go the same way, so there's the 4 pumps beneath them, 4 pumps beneath them, 4 pumps beneath them. They all share, in their distinct groups, they share like waste bags and vents and stuff. So there's essentially 2 solenoids for the first stool, 2 solenoids for the second stool, and 2 for the third stool. So tubing-wise, the separate stools aren't connected at all, but electronically they share the same setup. Okay, so let's see here. Yeah, so basically the way the tubing works is that we have a nice layout of it, which I can maybe show you guys a picture of, but the basic idea is that in the top of the cell, one port is for refilling, which is the middle one. The right port there on the top of the number 1 cell here is for venting, and the left one is for the transducers, which we don't have hooked up right now. And then in the bottom, the right one is for pressurizing, venting, and draining, and the left one is for the transducer. So currently we don't have the transducers in because our printed circuit boards aren't in yet, so we just have all those ends capped. Yeah, so one thing to note about the seal made around here is that essentially the curve, it's a curved portion and then it levels out there at a tangent. So the walls go in the short way are just flat, and then the middle portion is curved. So the screens are either curved at the specified radii, like 2 inches, or they are flat. So yeah, there's no portion of the screen that's bent back, and then even the silicone clamp is, it's never flipped back and bent at any awkward angle. This is the main reason why we machined the cells. Cool. So let's see. So the tubing. So then so I said the right one is for the venting. So the venting is through a solenoid, and that will vent into a bag, and that in the bag will capture any fumes that come out and also any fluids, but we might not need the bag in the end. That's just kind of here for testing. And then the middle one is for refilling. So refilling, we use the same bags here. So we have these 4 bags for this test stand hooked up on top. So this bag here would it's essentially we fill it from the top, we cap it, and then there's just a switch right here that you push, and then you have gravity refill the bag. Or refill the chamber. And these bags are nice because they're completely sealed, unlike the syringes, and they can hold a lot more volume. We have them taped in half right now so they don't hold too much volume, or so they don't spread out too much. Yeah, all the tape up there isn't actually sealing anything, that's just holding the test setup together. Cool, so that's the venting. So then, yeah, for the bottom half of it, it's kind of messy down here. Obviously, this whole pile of electronics will be neater in the actual box, but right now it's just sprawled out on the table. So from the bottom, that connector does both the venting, the pressurizing, and the draining. So the way that works is that it essentially comes down, so that same tube comes down here, it gets split into a tree, one end goes into the pump, which we'll get to in a second, and then the other end comes over here, which networks together with all the other ones, and check valves stop them from interacting with each other. And then they come into this solenoid that's taped on the wall here. So that's the venting. So back to the T connector here. Just a reference, coming straight from the cell to the T connector. We just showed the venting. And the venting, yeah, they all vent via the same solenoid. And then they lead into the pump after that. These are our pumps here. So after the pump, so they connect together again. The nice thing about the pumps is they don't let any transfer from one side to the other without running, so being connected together isn't a bad thing at all. So yeah, there's a bunch of check valves which get kind of complicated when you try to explain them, but they're basically put in the right places to work. Okay, so yeah, so continuing through the pump here, we have, let's see here, so it trees, and one end is a check valve that's just pointing into the tube. So what this allows, that's actually where all the air intake comes from. So when all the pumps turn on together and start running, they all pull air through here, and then that's what they use to pressurize the cell. So we've covered venting, pressurizing, and then draining. There's the T here, and the other check valve goes the opposite way, and that one runs into a drainage bag, which is that big white thing there. So a lot comes out of the bottom port there. That does draining, venting, and pressurizing. And then we explained the top. And the reason why the number of ports are the way they are on the different sides is basically the way it worked out with check valves with what needs to be pressurized where. So basically they share things they can share between a group of 4 cells, but they don't share anything that will cause pressures to go between the chambers at all. So that's the setup. So we have the fluids bags for the first stool here, but the second two don't have the fluids bags hooked on them yet, just because it doesn't make sense to set up such an elaborate test. Oh, well actually that's not the reason. The reason was that we don't have enough screens made to run all the tests. You can see those ones don't have any screens in them, those ones partially have screens. Our reduced gravity logo. Anyway, we're going to run 4, but the electronics right now will turn on all of the pumps together. So 1, 2, and 3 network of pumps, and they'll also turn on all the solenoids together. So the top solenoids are all controlled together, and the bottom solenoids are all controlled together. These are the top solenoids for the other 2 guys, there and there. So the electronics are hooked up for all of them, but essentially the tubing is just not. The tubing's hooked up entirely for one of them. So pretty much the main work we have left to do is just to plug in the transducers, which will pretty much be what it entails, but since we're printing circuit boards, there's a little bit of soldering to do, but mostly just plugging things in. So that won't take too much time, but then the big thing left to do, which we're definitely behind on, is the box, which is why everything is on pink foam and stools currently. But we are working on the box a lot, machining it and stuff, just to get it so that it's basically the externals of the box are mostly okay. Some of it got damaged, some in shipping, so we're fixing that. But then also we need to put the mountings in. So because the setup here is different, it has pumps and different shaped cells and stuff. So we need new mountings for the internals of the box. So you've seen the pumps and the solenoids, and those all lead to our relay board here. So basically the way that works is that let's see if we can zoom in there. There we go. So let's get something pointy. So on an individual one of these, the middle screw terminal here is just like the power cord. So the power cords are all split to go into the middle here of the 3 things. It's like 1, 2, 3. So the middle one there too is the power cord, and then this one is essentially just the power to the motor. So power to the solenoid or power to the motors. And then with the computer we can switch this relay. So it basically just right now it has these 2 connected, so we have nothing plugged in there. And then when we switch the relay, it'll connect these 2, which will turn on the pump. So basically this is their power, this is their voltage wires, and then their ground wires are already connected, so this basically just breaks or makes the circuit. Cool. And then this is connected via our heavy-duty wire here to the Arduino. And then the Arduino is connected to the computer.